Okay, here we go. Number 1. What are the zeros of this polynomial function? Choose all that apply. So what is the question asking you to find? What are the zeros? Well, what's the definition of zeros? Right, so we see that it bounces off of the x-axis at 1, but isn't that still a 0? It crosses through at 2, and it crosses through at 3. But over here they have them written as an ordered pair with an x and a y value. So what is the ordered pair for this point? 1, 0. What is the ordered pair for this point? 2, 0. And what is the ordered pair for this point? 3, 0. And think about it, guys. They're zeros because every time the y value is 0. Okay? So 1, 0, 2, 0, and 3, 0, which would be D, B, and F. Any questions about that one? Number 2. At what point is the relative minimum point located on the graph? Well, let me go ahead and fix something real quick. These are numbered wrong on here. It should be numbered -1, -2, -3. And then +1 up here. So, somebody go up to the board and place your finger on the relative minimum. Okay, Anna. No, I mean like on the graph. Right. Why? This is a relative minimum. What are these 2 points called? Those are absolute minimums because that's absolutely the lowest point those graphs will ever, or that graph will ever have, right? But this is the next lowest, which is called our relative minimum, and isn't that located at 0, -1? So C. So do you understand the difference between an absolute and a relative? Number 3. Identify the following zeros of the polynomial function and plot the zeros of the polynomial on the coordinate plane provided. You will only be plotting the points. You cannot connect them. How do you plot a point for the factor x plus 7? Where do you plot it? Right, -7. Where do you plot a point for the factor x minus 1? Right. And where do you plot a point for the factor x minus 6? And that's all you'll have to do on that question. You'll just take the mouse and plot the points.
You play.
Yep.
You play.
You'll just take the mouse and you'll click, and it'll plot points for you.
Got to be a twist to this.
Yes. So, has anything we've done so far been difficult at all? No. All right, number 4. Use the graph of the polynomial function at the right to answer the question. The end behavior of f of x can be described as. Okay, well, first of all, I want to fix a typo. If this y-axis is labeled as f of x, then these should both say f of x. If it had said g of x, then these would have stayed g. But it was labeled f, so we need to call these f of x. But that's just a typo. So, as x approaches positive infinity, what direction is that telling you? To the right. X only goes left or right, and positive would be right. So if you go to the right side, you're going down forever, which is -infinity. And yes, you will be expected to write out the entire words. There's not going to be a little symbol for you, so you'll have to write it all out. We are going to put a word bank on the board. That way you'll know how to spell these words. Okay? Now, some of the words that we put on the board may not be used on the test. Because that would make it too easy if we literally just put the words that are going to be answers. That would make it too easy. No. All right. As x approaches -infinity, what direction is that? Left. So if you go to the end of the graph on the left side of it, how's it going? -infinity as well. Okay, any questions about that one? Okay, next question, number 5. Use the graph of the polynomial function f of x below to answer the question. Which of the following best describes the characteristic of the polynomial over the interval x equals -1 to 1.5? So what I'm going to do is I'm going to go to x equal -1, which is right here. and I'm going to go to x equals 1.5, which is right here. What's going on between those two lines I just drew? It's decreasing, right? So this represents an interval of decrease. No, right, the absolute minimum is way over here. That's a relative minimum. No, because the relative minimum is not from there to there, it's only right there. What's going on from -1 to 1.5 is an interval of decrease. Does that make sense? Okay, next page. Number 6. Which of the following statements could be true for the graph below? Choose all that apply. Okay, so choose all that apply. The polynomial has 2 intervals of increase. True or false? True. Okay, I see that it increases right here, and I see it increasing over here. B, the polynomial has no real roots. True or false? False. I see roots. I see one at 1, one at 2, and one at 3. So B is false. It has real roots. Yes, roots is just another word for zeros or x-intercepts. C, the polynomial has 4 real roots, one with a multiplicity of 2. That is true. Even though we only see it hit in 3 different places, 1, 2, and 3, doesn't that one count twice because it's a bounce? Multiplicity of 2. So that's why it totals up to 4. Also, guys, it's even, which means you're going to have an even number of roots. The polynomial has 2 real roots. False. We just said it had 4, so that can't be true. The polynomial has 1 interval of increase. False. We already said it had 2. And F, the polynomial has an absolute minimum. Yes. Isn't that right here the absolute minimum? Okay. Any questions about that one? Number 7. Consider the following polynomial and answer the questions below. This polynomial has blank terms. No, you don't have to graph this one to answer these. The polynomial has blank terms. 3. Negative 4x to the 5th is one term, negative 2x is the second term, and 6 is the third term. The negative 4 in the expression above is an example of a or an. You're right, it is leading coefficient, but I'm pretty sure on the test, all they want is coefficient. If you were to write in leading coefficient and it did mark it wrong, I would fix it for you. But I'm pretty sure on the test, all they want is coefficient. They don't care that you put leading, even though it is. How many constants are included in the polynomial expression? 1. There's only one constant and it's 6. But they don't want you to type 6. They want you to type 1 because there's just one constant. They said how many, not what it is. Number 9. Which of the following expressions is equivalent to the expression x squared plus 8x plus 15? C is correct because this is one of them where you have to multiply to 15 and add to 8. Well, the numbers that multiply to 15 and to add to 8 are 3 and 5. That's all you do. It's just bubble method. Any questions? All right, number 10, identify all of the expressions that are equivalent to this expression. Okay, so we have 3x squared minus 6x minus 24. If you're asked to factor that, what would you do first? We're not asked to graph. They didn't say graph it. These are the answers. You're not going to get them. You want to, first we want to pull out a GCF. Can't we pull out that 3? And when you pull out a 3, you're basically just dividing everything by 3, right? So what does this term become? 1x squared. And then what does this term become? Negative 2x. And what does this term become? Negative 8. So look, that matches A. However, choose all that apply. And the reason it says choose all that apply is because you can go one step further. Now we can bubble method that by looking for 2 numbers that multiply to negative 8 and add to negative 2. What numbers will multiply to give you an 8? Okay. But one of them needs to be negative so that they multiply to give you a negative. And which one needs to be negative so that when you add them you get a negative 2? Negative 4 and positive 2. So C is the other one. A and C are both simplified versions of that. Okay, next page. Okay, number 11. Graph the following on your graphing calculator. F of x equals 2 times x plus 3 cubed minus 3, and describe the end behavior. Let me go ahead and show you that the picture, like this picture belongs to A. This picture belongs to B. This picture belongs to C, and this picture belongs to D. So what I want you to do is I want you to graph it in your calculator and then tell me which one is right. It seems like it, but it's really way easier than it is. Remember, the picture is above the letter. So like this is the picture for A, this is the picture for B. So when you graph that on your calculator, which picture does it look like? The last one. So do you even have to do end behavior? No. The only one that looks like the graph is D. It's not like two of them look like this. So you don't even have to worry about end behavior, do you? Okay, next page. This is the second part of the test, but you'll also be taking this tomorrow because it's only 17 total questions. Yeah, the whole test is only 17. Use the fundamental theorem of algebra to find all roots of the polynomial equation. Now, what's another word for roots? Zeros. Right. So what do you think you should do first if you're trying to find the roots? Graph it. So go ahead and graph it. Okay, when you graph it, how many zeros does it have? 3, and where are they located? Okay, so -5, 1, and 3. A, C, and E. Alright, number 2. Fill in each blank from the choices provided that is a factor for the provided polynomial expression. Alright, so what would you do here? Graph it, because you're trying to figure out the factors. So y equals x cubed minus 5x squared plus 2x plus 8. Okay, how many zeros does it have? 3. So this zero is at -1, right? What's the factor for that? X plus 1. When you write them as factors, you have to write them with the opposite sign. Yes. Okay, the next one is at +2, so its factor would be x minus 2. And then the third zero is located at 4, so its factor is x minus 4. Now let me point out something to you in the directions for this problem. Fill in the blank from the choices provided. There are not going to be any choices provided. Okay, you're just going to graph it and look at the zeros and write the factors representing those zeros. And it says a factor. If you just write one of those 3, you'll get it correct. Because it says a factor. So you could have just typed in the x plus 1 and been done and you would have got it right. Because they only want you to write a factor. So try the next 2 by yourself. Here's the graph of it. So this is a 0 at, so its factor would be x plus 4. So technically, you're done after you do that part, but we'll just do the other 2 just for practice. Okay, where's this next one located? Isn't that in between 2 and 3? So we'll say like 2.5, so wouldn't that be x minus 2.5? And then where's the third one? 3, so x minus 3. Okay, and then what factors did you get for this one? X plus 3? x minus 4. That's it. And an x squared. Think about it. It has to have 4 because it's degree 4. There's 2 of them, and there's the third one, and there's the fourth one. Because wasn't there a bounce at 0, which counts twice? Alright, but remember, tomorrow you only have to write a factor, so one of those will be sufficient. Like for this one, you could just put x plus 1. For this one, you could just put x plus 4. For this one, you could just put x minus 4. It doesn't matter which factor you put, just one of them. Or x squared. Number 3, how many zeros exist for this polynomial? 3. When there's 3 factors, there are 3 zeros. 4. State the multiplicity at the root of -2 for the polynomial function. Okay? A root of -2 would be which one of these factors? The second one. A root of -2 would be an x plus 2, correct? So what is its multiplicity? 3. So D. Okay, next page. Here's the hard ones. Yeah. Use the fundamental theorem of algebra to find all roots of the polynomial equation. X cubed plus x minus 10 equals 0. Choose all that apply. First thing we do is graph it. So y equals x cubed plus x and then minus 10. Okay, it's degree 3, so we know there's going to be 3 solutions. But when we graph it, we only see it cross the x-axis one time, and where is that one time? Positive 2. So it has one real solution, because that's the only one we can see, and it's located at positive 2. So I already know A is one of my right answers. Now, since I know that's my only real solution, what could I mark out? Right. The other 2 have to be imaginary, correct? So they have to have an I. And all of them do except for C. So I marked out C. Now, how do we use that one real 0 to find the other 2? Right. Synthetic division. So we put a 2 in the box, and then what numbers do we bring down? A what?
1, 1, 0, negative.
1, 0, 1, negative 10. Okay, so now what do we do with those numbers? Bring the 1 down, and what do we do with it? Right, 1 times 2 is 2. What do we do with those numbers? Add them, and they make a 2, and then 2 times 2 is 4. Now we add those, and they make a 5, and we multiply those by 2 and make a 10. Okay, let me give you another hint. For all of these type of problems where you're looking for the imaginary solutions, you're going to get a remainder of 0. So if you don't, you probably should start over. Okay? Now, what does this become? It becomes a trinomial, a quadratic trinomial. So 1x squared plus 2x plus 5. And what can we now do with that trinomial? Right. Identify the A, B, and C, which would be 1, correct, and then we're going to plug it in the quadratic formula. Okay, so x equals, you tell me what to write. Right. Anything that you're plugging in for A, B's, and C's, put them in parentheses. All over 2 times 1. Now what should you do next? Discriminant. First get your discriminant, which is the b squared minus 4ac. Type in the b squared minus 4ac and tell me what it is. Negative 16. And then all over 2, because 2 times 1 is just 2. So now look. x equals negative 2 plus or minus. What is the square root of 16? 4, but since it's negative, you put an I, and then at this point, look up for a second so that you don't miss it trying to copy. I'll give you time to copy in a minute. Go ahead and put the 2 under each part, just so you don't forget that each of them gets simplified by 2. And so right here, this becomes a negative 1 plus or minus, and this becomes a 2i. Now, there's a typo on this review sheet. This should have been a negative 1, and this should have been a negative 1. And aren't those the two answers? A negative 1 plus 2i and a negative 1 minus 2i? Okay, now remember, I know that this is probably the hardest problem on the test, but you can type them in your calculator. Watch me do it. Okay, just watch. And then I'll give you time to copy if you still haven't finished. We'll be copying while it's frozen. How are we going to type it in? No, I was going to move it and let y'all copy while it was thinking, but it was frozen like on the screen. Okay, so look. I'm going to retype in x cubed plus x minus 10, but I'm going to type in like 2 in both x's. Then I'm going to type in negative 1 plus 2i in both of them, and then I'm going to type in negative 1 minus 2i in both of them. Okay, so let's start by typing in the 2 for every x up there. 2 cubed plus 2, oops, thanks, 2 cubed, and an arrow over to get it back down, plus 2 minus 10. If 2 is indeed one of the answers, it will equal what? 0, and it does. So I confirm that A is right. Now let's type in F and see if it's right. Negative 1 plus 2. I is right there in blue, so to get it, you have to hit second first. And then cube it. Now come back down, plus, parenthesis, another negative 1 plus 2i, and then minus 10. When I hit enter, I get 0, which confirms that that is the right answer. That's our second solution. Now for the third one, I'm just going to highlight it and copy it, because I'm pretty much typing in the same thing, except for I need to change the plus to a minus. And look. Now watch if I type in one of these other answers that we've already said is wrong. I'll type in 4i. So 4i cubed plus 4i minus 10. So see how I just retyped in x cubed plus x minus 10, but I put 4i? Does not give me 0, does it? So you're looking for the choices that when plugged in the x's give you 0, and those are your answers. So if you can't do all of this, try to just go through each choice and plug them in until you find the ones that equal 0. And you know, since it's cubed, there's going to be 3 of them that are right. So now while people are finishing copying this, go ahead and try number 6. Either use the method I taught you, or just start plugging them in until you find the right ones. Okay, what's the first thing you should do? Graph it. It has one real 0, and where is that one real 0? Negative 3. So I already know C is one of the right answers, and since there's only one real solution, that eliminates A, because the other two solutions are imaginary, so they need an I in them. Now, how do we use that negative 3? Synthetic division. What numbers come down? Right? So the 1 drops, multiplies by the negative 3 to become a negative 3, and when you add those, you get a 0. It multiplies by the negative 3 to make a 0. When you add those, you get a 4, and that multiplies by the negative 3 to make a negative 12 for a remainder of 0. So doesn't that become 1x squared plus 0x plus 4? So technically, if you wanted to go with quadratic formula, you could. Your A would be 1, your B would be 0, and your C would be 4. But when your B is 0, you can just write it like this, correct? And now just set it equal to 0 and solve for x. By subtracting 4, that gives you x squared equals negative 4. Then square root both sides. And so x equals the square root of 4, which is 2. But since it was negative, it's an I. And we always put plus or minus. So a positive 2i and a negative 2i. And then you could have plugged those 3 in to see that they equaled 0. Does everybody understand what I mean when I say plug them in? Okay, now, but if you don't remember to do this method that I just did, you could always use quadratic formula. Just 1 is your A, 0 is your B, and 4 is your C. You'll get the same answer at the end. But this is easier if you remember to do it. Because on the other one, the B was 2x. To use this shortcut method, the B has to be 0. Because think about it, like up here, if we set that equal to 0 and subtracted the 5, we're still going to have all that to deal with. Like, right, they won't combine. Like, there's nothing to do. That's why you have to do quadratic formula. But down here, when you only have the x squared and the constant, you can move the constant over and then just square root it, because there was no middle term to deal with. Okay, next page. Okay, on the test, it's going to look pretty much like this. It's going to have a lot of boxes, and then it's going to have boxes down here that you're going to have to take your mouse and drag them up into the correct place. So what do you think the first thing we should do is? Graph it. Graph the polynomial. So y equals x to the 4th minus 2x cubed minus 3x squared plus 3x. Graph it. Okay, so first let's talk about end behavior, because that's the first box. As I go right or as I go left, what are the y's doing? Up. Now, how many boxes down here represent end behavior? 2 of them, right? Well, which one says that you go up on both sides? This one. So you're going to write this up here. X approaches infinity. F of x, yeah, you'll just slide it up on the test. You won't have to write it. And then x approaches negative infinity. F of x approaches positive infinity. They go up on both, no matter which way you're going on the x-axis. Yes? It was extra. One of them got attached to somebody else's. Okay, so we use this box, and think about it. Isn't this also end behavior? And there's no other end behavior on here, is there? So we're not going to use that one. It says up here that some may not be used at all. Okay, now let's go to something like absolute min and absolute max. Does this graph have an absolute minimum? Guys, the absolute min is, right, it's the absolute lowest part the graph will ever have, and that's right here. Well, isn't that right 2 down 6? Okay, so let's see if that's one of the choices. It is 2, negative 6. Okay, so I'm going to check that one off because I've used it. All right, absolute max. Does it have an absolute max? Why not? It keeps going up forever, so you would never find the absolute highest point because it'll keep getting higher. So which box do you think you're going to drag to that one? Does not exist. Okay, now I'm going to skip these because to me those are the hardest. Let's go to relative min and relative max. Does it have a relative min? Which one is it? This one right here, correct? Because that's your absolute min, so that's your relative min. Isn't that negative 1, negative 3? Okay, well, do we have something that says negative 1, negative 3? Right. That's pretty close to negative 1, negative 3, isn't it? Negative 0.9, negative 3. And that's how it is on the test. That's why we made it decimals on the review sheet. Okay, does it have a relative max? Isn't the relative max that hump right there?
Yeah.
And where is that located? Well, let's look down at our choices that haven't been used. 0.4, 0.6. Okay, so now we've used that one. Now we have 4 boxes left, and we have to do intervals of increase and intervals of decrease. Well, it makes sense that I have 4 boxes left because don't I have 2 of each, 2 increases and 2 decreases? Okay, so let's start with this first increase. When does this start increasing? Oh, I'm talking about the increase. -1 to about, I don't know, like, so out of these four, which one would that be? This one, right? -0.9, +0.4. Okay, now let's do the other interval of increase, which is from here to here. So when did it start increasing on this side? It looks like about 2, doesn't it? And then it increases forever, so that's 2 to infinity. So go ahead and be writing it. Mine froze up again. Okay, so 2 to infinity. Okay, and now it's kind of common sense that these are your two intervals of decrease because that's all that's left, but let's just check them. Negative infinity to -1, basically. Isn't that like -1? Doesn't it decrease from negative infinity until right here, which is about -1? And then doesn't it decrease again right here from, like, I don't know, 0.4, I guess is what that is, till 2? And then what those two say? So negative infinity to -0.9, and then 0.4 to 2. Are there any questions about this one? Okay, I really, really do not think this test will be that hard for you if you just put in a little effort tonight and look over